Just a second. Yeah. So when we set up the Azure Industrial IoT team, we said we want to do things differently. Obviously, we had a lot of experience with Windows IoT in the manufacturing space, and we realized that the number one problem that customers face in bringing their technology and their applications forward to smart manufacturing Industry 4.0 applications is vendor lock-in. Not being interoperable with different systems and, basically having to build adapters and wrappers and, bending over backwards to make these systems interoperate with one another. So we said we want to do things differently, and we set these 4 goals or these 4 pillars of our platform strategy, starting with open source. So everything we wanted to do in this space and to this day is available open source on GitHub. Of course, we built an open platform based on Azure, where you basically pick the services that you need and then only pay for its use. You don't license anything anymore. Open standards, OPC UA being at the core of that strategy. And then probably most importantly, open data models. Because fundamentally, your architecture is based on your data model. Everything goes from there. You pick your data model first, and you build out your strategy and your architecture from that. So what do you really need for data interoperability? Well, you need 4 things. And I created a little analogy which works great for my executives who know nothing about manufacturing, right? So I needed an analogy to really explain it to them. So let's say you're an author and you have a great idea for a new novel. You want to publish that novel to the world, and obviously you want that novel to be read by the most readers possible. So you need to pick 4 things to achieve that goal. Well, first of all, you need to pick an interface of how you're going to transport your novel to your customers. In this case, a book, right? Then you need a data format so that people can actually read your novel. In this case, let's say you pick the Latin alphabet. Sorry, a data format. I said data model. I mean the format, of course. And then the data model is the English language, right? So that's basically the words defined by the English language. And then how you put those words together and what those words mean and the characters and the plot and everything else, that's the semantics. Right? When you have all 4 things, then you have an interoperable solution that most people can make use of. And in my opinion, data interoperability in the industrial space is exactly the same. So here's an example for OPC UA. And OPC UA is a big piece of technology. It actually covers all 4 aspects of interoperability for you. So you don't need to do anything else, you don't need anything else but OPC UA to achieve that interoperability. So let's say you have a KUKA robot. Here's one example. So the interface of this thing is an OPC UA server, and you connect to it using an OPC UA client. The data format is a binary format that is defined in the OPC UA standard. The data model is the OPC UA information model that is contained in the controller of that robot. And then finally, the semantics, and this is where the VDMA comes in. The VDMA is the German Machine Builders Association, and they actually created this robotics companion spec. And a companion spec, for those of you who don't know, is a specification that is released through the OPC Foundation, built by somebody else, in this case the VDMA, but it accompanies the core OPC UA spec. It becomes part of the standard, hence the term companion spec. Here's another example of a much simpler device. This is a Siemens energy meter. It has a Modbus interface. And as you probably know, Modbus is not discoverable. You can read a register and write a register. You have no idea what the data means. So you need something else to explain the data to you. So in this case, we want to map this Modbus device to OPC UA because OPC UA has all 4 components. Therefore, it's a good idea to map everything to OPC UA to create that consistent data model, consistent interface, and so on. So you map it to OPC UA, right? But to do that mapping, you need to understand its data model. It does have a data model. It's in a PDF someplace, and it says register 1 is voltage between live and neutral, right? And actually, as we found, the Web of Things, which is a W3C standard, covers that part. It actually also covers the interface to some extent, so it explains where to read what data tag from. It's all covered in the JSON LD file. And that's basically where the semantics come in. This Modbus protocol binding, where it tells you exactly where each register is, how to read it, and what the data means, that's all covered in Web of Things. So really, for OPC UA-enabled machines, it's great. You can discover them. You can read all the tags out of the machine. You know the semantics. For things that don't support OPC UA, because either they're old or they're too simple, that's where things like Web of Things come in really handy. And we have several working groups now between the W3C and the OPC Foundation to cover how to map from Web of Things to OPC UA. Okay, so why is Microsoft really interested in OPC UA? Well, the story started with OPC Classic, which was obviously based on Windows COM. And then eventually the OPC Foundation was set up, and Microsoft was a member since the beginning. Obviously now the OPC Foundation has over 1,000 members, so we've grown quite significantly. And it's obviously an IEC standard since 2012, which is also quite good. But really we've, been part of the foundation since the beginning, and everybody just kept paying our dues, our fees. Nobody really made use of it, right? Until I came along and I said, well, this is really interesting, and I think it's exactly what we've been looking for to get that data interoperability going. And, talking about open source, we contributed over 6 million lines of code to the OPC Foundation to date, and we keep contributing more, because a standard won't get adoption unless you have a good open source reference implementation for it, where people can look at it and say, that's how it works. So that reference implementation, open source, is really important. And the reference stack that the OPC Foundation maintains was mainly contributed by Microsoft. But apart from the interoperability that it covers, in our opinion, it has the best data modeling capability in the industry. So you can model everything under the sun with OPC UA. It's very flexible, it's very simple. Everything is a node, and a node can have connections to other nodes. The OPC UA data model is actually a graph. Now, people find it hard to understand what's a graph, right? People know what a tree is, right? So you can have a root node, and then you can have child nodes, which have a parent of the root node, and then on and on and on. And a graph is just like that, but you can have more than just parent-child relationships. You can also have references to other nodes somewhere else in the tree. That makes it a graph. And OPC UA has that capability, and that comes in really handy. For example, you could have a tree of your production line where your MES is connected to various machines, but there's also a certain order in which products go through the production line until they're finished. So you can have a connection or a reference between different machines. That makes it a graph. And of course, there's these mappings, not just from Modbus or Web of Things, but from almost every other protocol and standard used in industrial automation. And that makes it so flexible, because no matter what interface or data model you might be faced with, you can map that to OPC UA, and chances are somebody's already done it, and you can just buy a product that does it for you. And then, especially these days, you probably read in the paper yesterday that somebody cut the data cable between Finland and Germany. Great. Security is becoming more and more important. So obviously Microsoft gets hacked every day. In fact, now we have over 600 million hacking attacks per day on the Azure cloud. 600 million. And they blame us for having poor security, right? No, we have very good security, and it's the 2 times when things go wrong that are you end up being in the paper, right? If you like it or not. But with the Secure Future initiative that we set up, this is getting #1 priority at Microsoft. So hopefully we won't be in the papers that often. And a lot of customers that I talk to now say, I need to go to the cloud because of the security, because I can't deal with the hacking attempts myself. I need somebody who has, I think it's over 6,000 employees specifically for keeping our data center secure. And it's probably an outdated number, it's probably more than that now, but anyway, we have a lot of security experts that are dealing with these hacking attempts and how to mitigate them. And OPC UA has the best security capabilities for the OT. So combining those security capabilities in the OT with the security capabilities on the IT is what it's all about. Okay, so if you look at the industrial automation pyramid, you've probably seen this before. As you can see, OPC UA covers the entire stack, right? And you probably heard about FX or Field Exchange, which is at the bottom. It's real-time capable, running on the sensor network or field bus. Then OPC UA client server is what most people associate OPC UA with. But since 2017, obviously, we also have PubSub, which is a publish-subscribe mechanism. We're going to hear more about this today. And then finally, we have an OPC UA REST interface. Most people don't know this, but OPC UA actually had REST capabilities since 2015. It was so buried in the spec, nobody found it. I always said it's the best kept secret. You can use OPC UA with REST. So we're going to change that in the next version of the OPC UA spec. It's a lot more prominent. It's open API compatible. I ran the working group, so I should know. So this is coming, and it's actually quite useful for quite a lot of use cases for standardizing supply chain data. So where does Microsoft play? Well, right now we're kind of playing in this area here. We have a piece of software that is an OPC UA client and a PubSub publisher called OPC Publisher, and a new one called OPC UA Connector. Don't ask me who came up with those names. I came up with OPC Publisher. I thought it was pretty good, but then marketing got involved and renamed it to OPC UA Connector. But anyway, and then of course we're also going to see if we can make use of the OPC UA REST interface in the cloud. UNS, the popular term if you like YouTube. So unified namespace is nothing but a consistent way to address all your assets worldwide. If you talk to some of the YouTubers, it's mainly focused on building it into an MQTT broker. I think that's wrong. I think the UNS needs to be where your data is. Because let's face it, when you query your data, you first need to query your UNS to get the metadata, to understand what asset it comes from and how that asset is connected to everything else. So in my humble opinion, the UNS should be part of where your OPC UA data ends up, which is usually in a time series database or a historian. That's where your UNS needs to be, not in the broker. Ask any broker architect or messaging architect. They always say the same thing. Don't abuse the broker as a database. It's not a database. And if you want to do queries effectively, you shouldn't have to query your broker first, then query your database or your historian second for the actual data. You need to do everything in one go for performance reasons. So how does that look for OPC UA PubSub? Well, as it turns out, this has been part of the standard all along. We just never bothered to talk about it. So you can address a tag in an OPC UA server by its ID, the node ID. But then, of course, a tag is only unique within a namespace, so you need to kind of know the namespace as well. And that's called the extended node ID. It includes the namespace. And of course, every server has several namespaces, and a server has a unique identifier, or is supposed to be unique, at least if you read the spec, which is called the application URI. And this may come as a shock to you, but the U in URI stands for universal, which means that it needs to be unique, right? So if you combine the application URI with the extended node ID, what do you got? You got a unified namespace where you can address all your applications, all your tags in a global way. And that's exactly what we're doing with the unified namespace in PubSub. So here's an example. Now, you gotta actually put something useful into your application URI. Don't call it server 1, or don't call it, put in the IP address. I've seen it. I've seen the IP address in the application URI. That's a mistake. You shouldn't do that. It needs to be useful information. For example, you could use the ISO 95 asset hierarchy. Wouldn't that be great? Remember, whatever it is, enterprise site, area line, work cell? Use that as the application URI. And if your OPC UA server doesn't allow you to change the application URI, don't buy it. It's a bug. And I've seen some examples where you can't change it, and I said, you gotta make that configurable. So anyway, then you end up with something like this. So this is the namespace. It actually has this tag in the front. So it's like something like packaging line 1, building 2, Munich, Contoso, whatever. And then the expanded node ID. That's the expanded node ID. And it is in the spec in part 6. You can read it there. So that's how, in my opinion, a unified namespace with OPC UA should look like. So a little bit about Azure IoT and what we did with OPC UA. So in 2017, we launched the Connected Factory. And for the first time, it really showed the capability of data interoperability. Because at Automatica in 2017, we used Connected Factory, and you see the dashboard here, to connect to all of these robots that we've never seen before. We didn't know what their data model looked like, but they told us it was compatible with OPC UA, and more specifically, compatible with the OPC UA robotics companion spec. So based on that information, we updated the dashboard to include the semantics of the robotics companion spec. And then the trade show started. We plugged in all the robots. They sent data through a Siemens gateway to the Azure cloud, and everything just worked. And that was a great moment, for me at least, to bring the message home and say, great. So now for the first time, we can build our IT separately from our OT. Because previously, you came to a factory, you enumerated all the machines, you've connected to them, you've tried to figure out the data model. Then you started, converting the data to something useful, and then you sent it to a dashboard, and then obviously that dashboard was tied to the data model that you picked. Now, you can rebuild your dashboard based on OPC UA companion specs and OPC UA, and you can just connect stuff at any time, and it just works. So that was really good. That was important, and it kind of set the course for our product strategy quite a lot. So as a next step, we built the cloud library together with SESMI in the United States and the OPC Foundation, of course, because we said, okay, well, if those semantic data models are so important, those companion specs, we kind of really need access to them from the cloud. So we need a library which includes all the companion specs, and preferably other OPC UA information models as well. And that's what the cloud library is. It has a REST interface, it has a GraphQL interface. It's hosted by SESMI and the OPC Foundation, so we have redundancy. And it's been running for years. We only had one outage, and I actually blame Azure for that, not the cloud library. So it's been running quite reliable for years, and it has over 150 OPC UA information models and companion specs in there right now, and there's probably going to be another 100 added soon. So how does it work? Well, the cloud library sits in the cloud, right? And for example, connectivity software, like your Forge or your Kepware or, I don't know, Softing data feed, can read, hopefully, the companion specs from the cloud library and use them to map your assets to a standardized semantic model. And then data is sent through the edge gateway and the cloud gateway to a time series database. Like I said before, that's where your data ends up. And then the time series database can also query the cloud library for additional semantic information that may not be contained in the PubSub messages. Now, with the latest version, which is coming out soon, of the OPC UA spec, we're adding quite a lot of detail to concrete metadata messages in PubSub. So a lot of the information that is in the cloud library will also be sent through the PubSub mechanism, but it's always good to have everything in one place and be able to query that data. Together with your time series data to do your analytics. Of course, nowadays it's all co-pilots, right? You gotta have co-pilots, right? And based on the results of your analytics, you can create actions that then impact your assets eventually through this return path. So that's the cloud library. So what does that look like in Azure? Well, we actually have two products now. We have Fabric and we have Azure, right? So Azure is platform as a service where you basically deploy what you need into your own Azure subscription and you put it all together in the way you want it. Or you can just say, you know what, that's too much for me. I just want a login. I just want to pay a monthly fee, and that's it, right? And that's Fabric. Fabric is our software as a service offering, which basically does the same thing that Azure does, but you don't need to manage any of it. So for both, we use OPC UA PubSub. In fact, we use Kafka, not MQTT. Personally, I prefer the Kafka protocol because I think it's more reliable. But it's still PubSub. Right? So the payload is the same. And then on Azure, we have a few services. So Azure Event Hubs is our Kafka broker. Azure Data Explorer is our time series database. And it also contains graph support now, which is kind of cool. And then it has its own dashboards. And in Fabric, it's exactly the same. So Event Stream is the name for Azure Event Hubs. In Fabric, they renamed everything. I don't know why, just marketing. But anyway, so Azure Data Explorer is called Event House, and then the dashboards are called Dashboard. Or you can also connect Power BI directly to it. So the thing about Fabric is it's a data mesh architecture, which means the data is all stored in one data lake, and all the databases and pretty much all the databases that we have are built into Fabric. But all the data is in one place and there's one copy. And that's one lake. So this is basically how it all works, but both OneLake and Event House and Azure Data Explorer connect directly to the cloud library to get the metadata. So let's talk a little bit about asset onboarding very quickly. So asset onboarding is, we use OPC UA to model everything. So if the asset doesn't have OPC UA built in, we map it through connectivity software to get that normalized, standardized, open data model with security. So a lot of the times as well, those machines, they don't have any security, and they're not going to. So you need a gateway to sit in front of the machine to build that secure network. Because yes, you do need to secure your OT network. Don't rely on the perimeter defense only. That's called defense in depth. You want to make it as hard as possible to the hacker to get to the data, and the hacker is driven by two things, time and money. So either he runs out of money or he runs out of time before he gets discovered. So you want to make it as hard as possible and as long as possible for the hacker to get to the data. That's why you need defense in depth. So this is our original product that we use is called Azure IoT Edge. It's based on a Docker runtime, and we use the Moby engine for Docker. We have an Edge agent that basically connects to Azure IoT Hub to get containers downloaded from IoT Hub to run on the edge, so you can deploy things from the cloud. And then we rely on third-party industrial connectivity software, which preferably runs inside a Docker environment, but of course we can connect to it if it doesn't as well. And then we have OPC Publisher, which I already mentioned, which is an OPC UA client on the left and a PubSub Publisher on the right to send data to IoT Edge Hub. An IoT Edge Hub is basically a broker that was originally based on AMQP. It also supports MQTT now. It has a store and forward mechanism built in, so if you lose the connection to the internet, that's okay. And you can also connect other applications that happen to run on the edge to it. And of course, everything is observable. So we have health monitoring, diagnostics, perf statistics, and all those kind of things. And why is there a red circle around this? I'll get to that in a minute. But this is basically the new thing, which has just become GA this week. Azure IoT Operations. It is kind of the next generation of our edge infrastructure. It's based on Kubernetes. Why Kubernetes and not Docker? Well, Kubernetes gives you high availability. And guess what? Most manufacturers actually want high availability for their edge applications. Other than that, it's exactly the same. So Edge Hub was renamed Data Flows. The broker is now a fully featured MQTT v5 broker. Again, customer demand. And OPC Publisher was renamed Connector for OPC UA. Don't ask me why, but that's the name they came up with. And there's still a little circle around this thing. What is that? Well, let's talk about that. So we said, why does it have to be that every single connectivity software has its own configuration interface, its own mechanism, usually a file format of, describing an asset? Why can't we just use Web of Things and OPC UA for that? And that's exactly what we did. And in fact, we created a reference implementation of what we think industrial connectivity software should look like. It doesn't come with a UI, it doesn't need it. It just uses OPC UA. And we actually poured the specification for the OPC UA interface to configure the industrial connectivity. And obviously we use Web of Things, which is a W3C standard, to describe the assets, and we pour that into an OPC UA companion spec. A companion spec doesn't have to be just a data model. It can also describe something associated with something like this. And this is basically what we did. So with this, OPC Publisher supports this control interface today. We're working on getting that same control interface built into Azure IoT Operations. And UA Edge Translator is available open source from the OPC Foundation GitHub under MIT license, so you can just use it. And I blogged about this, and I got 30,000 impressions in 3 days. So it looks like this is an important piece. And most importantly, we can actually generate those Web of Things thing descriptions using ChatGPT, or Copilot, as they're now known. So using the Azure Copilot or Azure OpenAI service, we now manage to get 90% accurate Web of Things files just by describing the asset make and model. So you can say, generate a thing description for a Siemens Centron PAC 4200, including its Modbus protocol binding, and you will get it. So really, there is no excuse not to use something like this to standardize configuration of industrial connectivity software. And that's just not important to folks like AWS and us, which obviously would like just a single interface to integrate. But guess what? Most manufacturers also want choice when it comes to picking their industrial connectivity software. So they think this is quite interesting as well. So how does that look like in an overall architecture? Well, this is basically one level down in the high-level diagram that I showed you earlier on. So here's your edge gateway with Azure IT Operations in it. Here's the edge translator. Here's the command, control and what's it called? Command path for the cloud action sends data to UA Cloud Commander, which is also available open source from the OPC Foundation. And here's the cloud library connecting to Azure Data Explorer. The rest is exactly the same. And yes, the edge gateway and everything in it can now be controlled through Azure Arc, which is our control plane on the Azure cloud for things like edge gateways and servers and Kubernetes clusters and everything else. So digging in one level down, we also did an SAP integration because a lot of folks use SAP. So that works through Azure Logic Apps. It works quite well. Once you figure out how to configure SAP, which I almost pulled my hair out trying to get that working, but with SAP's help, we actually got it working. Rüdiger Fritz, actually. He helped me in the end because I said, I don't know how to use the system. But of course, it's not what you know, it's who you know. So Rüdiger, I called Rüdiger and he helped me. And then finally, we also now integrate the asset administration shell, which I'll talk about a little later. Excuse me. So this is all available open source, including a tutorial on how to use it, and a one-click deployment. So you can click on that Deploy to Azure button. Everything is deployed for you, and you just use it. So what does that look like when you want to migrate from an existing Azure IoT Edge infrastructure to Azure IoT Operations? Well, here's an example that I've used with some customers. You can deploy both side by side to ease with the integration. So you pick your industrial PC, or that's now called Azure Local, which is the new name for Azure HCI, Azure Stack HCI. You can, on this HCI cluster, you can install VMs and you can install Kubernetes. And then the VM is something you'll need for Azure IoT Edge, and the Kubernetes cluster is something you need for Azure IoT Operations. And then the big difference is that IoT Edge is tied to IoT Hub, while IoT Operations is tied to Azure Event Hubs or Event Grid. Event Grid is also possible. Event Grid is our MQTT broker in the cloud. And then everything flows through either Azure Data Explorer or to Microsoft Fabric, as I showed you. And yes, you can control everything through Azure Arc, but apart from that, it's exactly the same. So this helps customers that have used Azure IoT Edge and want to migrate to Azure IoT Operations, but don't just flick a switch, but ease into it. So that's the way to do it. And you see there's two arrows here. Why is that? Well, like I mentioned, Fabric also includes Azure Event Hub, so you don't actually need an Event Hub necessarily with Fabric, but you can. And with that, I thank you, and I wish us all more peace in Europe. Thank you. How am I doing for time?